A hot air balloon is rising straight upward with a constant speed of 6.5 meters per second. When the basket of the balloon is 20 meters above the ground, a bag of sand tied to the basket comes loose. Letter A, how much time elapses before the bag of sand hits the ground? And letter B, what is the greatest height of the bag of sand during its fall to the ground? The best example of motion with constant acceleration is the free fall. Free fall is the motion of an object subject only to the influence of gravity. Ang concept ng free falling objects or simply the free fall, walang ibang nag-i-exist na acceleration sa motion na to kundi yung acceleration due to the gravity only, and that is the 9.81 meters per second square. So it was Galileo na una nagpakita with his own experiments that yung falling bodies ay gumagalaw with constant acceleration. And also, si Galileo rin yung nagsabi that yung objects sa may iba't ibang weight or with different weight ay nagfo-fall with the same acceleration provided that yung air resistance sa sobrang liit ay ini-ignore na. Before we go directly to the examples of free-falling bodies, ano ba talaga ibig sabihin ng free fall? To explain further, the word free in free fall means free from any effects other than gravity. Walang ibang nag-i-exist sa kanya kundi yung gravity lang. For example, in free fall, i-assume natin that yung object's motion is not influenced by any form of resistance or some friction. Let's look at this figure. So we have two objects here sa figure natin, feather and an apple. Dito sa figure na to, in the absence of air resistance, walang hangin na nag-e-effect, all objects fall with the same acceleration regardless of their mass. For example, walang ibang hangin na tumatama dito sa feather and dito sa apple. Pareho sila ng acceleration. Unless may darating na hangin and ihangin yung feather, mag-iiba na sila ng acceleration kasi may effect na dun sa feather other than gravity. Whereas dun sa apple, gravity lang yung nag-e-exist. Next figure, this is a man na tumalon sa trampoline. So, whether this man is on the way up or nandun siya sa pinakatuktok ng pagtalon niya, peak of his flight, or pababa na siya, this man is in free fall pa din. Yung acceleration niya downwards with the acceleration of the gravity. Nag-accelerate siya gamit lang yung acceleration ng gravity, and only when he is in contact with the trampoline dito, pag nagkaroon na siya ng contact dun sa surface ng trampoline, dun lang magbabago yung kanyang acceleration. As long as nandun siya sa mid ng kanyang flight, free fall yung kanyang motion. Last figure, volcano throwing a lava. Again, in this figure, in the absence of air resistance, itong lava bombs na ibinubuga ng volcano ay pwedeng tumama dun sa water na nakapaligid sa kanya with the same speed they had when they were blasted into the air. Another example of free fall itong lava. Next, take note naman that yung word na fall in free fall does not mean that yung object is necessarily moving downward or pabagsak. By free fall na concept in physics, we mean that any motion under the influence of gravity alone. So, kung for example, magdadrop tayo ng ball, free fall yun. If you throw a ball upward or downward, it is in free fall also as soon as it leaves your hand na nagbato. Again, an object is in free fall as soon as it is released, whether it is dropped from rest, thrown downward, or thrown upward. So, in all the examples and calculations na gagawin natin in the later chapters, and dito sa examples na to, ang gagamitin natin na value ng gravity is 9.81 meters per second square. Take note that yung acceleration due to gravity natin na 9.81 meters per second square are always positive downward kasi ang direction lagi ng gravity natin is always downward. Sa free fall, kapag nag-solve na tayo ng problem at yung object is pataas, ibig sabihin, directly opposite na siya sa gravity, negative 9.81 meters per second square na yung kanyang acceleration due to gravity. In motion at constant acceleration sa horizontal direction, these are derived equations of motion na nagamit natin from the previous lecture video. Whereas sa freefall naman, vertical na yung ating motion at constant acceleration. Lahat ng acceleration ay papalitan natin ng acceleration due to gravity. Ito, G na ang ilalagay natin. Ito na yung gagamitin natin sa pag-analyze and pag-calculate ng free-falling bodies problems. Example number 1. A fruit drops from a tree and falls to the ground 3.15 meters below. Letter A. How much time does it take for the fruit to reach the ground? And letter B. What is the fruit speed just before it hits the ground? For this problem, we have our figure here. Ito yung fruit na yan. And ito siya nung nahulog na. In this figure, pipiliin natin yung origin to be at that drop height of the lemon. Ito yung ating y sub o. Or pwede rin naman kung gagamitin nating variable is x pa din. So, ang ginamit lang natin dito is yung y na since vertical na tayo. And we let the positive direction be downward, pababa. Ito yung positive. With these choices, yung ating initial position, yung y sub o is equal to 0, of course, kasi yun yung starting point niya. And yung acceleration natin is the acceleration due to gravity, which is 9.81 meters per second square. Kaya hindi na binigay sa problem natin yung acceleration. And the ground is at eto, from here hanggang dito, ang kanyang y is equal to 3.15 meters. Ito yung height na bagsakan ng fruit natin, 3.15 meters. And of course, yung initial velocity natin dito ay 0, v sub o is equal to 0. Dahil yung fruit natin ay nahulog from rest out of the tree. Sa problem, walang sinabing air resistance, so we can directly ignore the air resistance in this case and model the motion as free fall lang. Ibig sabihin, we can assume a constant acceleration equal to gravity na 9.81 meters per second, and gagamitin natin yung equations of motion na na-derive natin. For letter A, we are asked to find the time of fall when we know the distance. Alam natin distance, we have 3.15 meters. Yun yung distance na pinagbagsakan ng fruit from the origin dun sa y sub o natin. And for letter A, ang gagamitin natin na equation is y equals y sub o plus v sub o t plus 1/2 g, or yung acceleration natin due to gravity, times t square. For b naman, pwede nating i-relate yung velocity to time. And ang gagamitin natin sa letter b is the equation v equals v sub o plus acceleration due to gravity times t. Or we can relate the velocity to position. Ang gagamitin natin isa, pwede natin gamitin na isa is yung v square equals v sub o square plus 2g delta y, or sa original derived equations of motion natin, delta x yan. Let's start first with letter A. Alam na natin yung initial position y sub o, this is 0, so 0 na ito. And yung initial velocity natin, v sub o is 0, 0 na din ito. Alam natin yung gravity and alam natin yung final position, which is 3.15 meters. Yun yung ilalagay natin sa equation natin. We have y equals 1/2 times g times t square. Solving for that time, ito yung sinasolve natin, we cross multiply, so this will be 2y equals gt square. And dividing both sides by g, para matira yung t natin, cancel. Baliktarin natin, t square equals 2y over g. Solving only for t, naka t square pa to, so we take the roots of both sides para makancel yung square. We have now t equals the square root of 2y over g. And substituting the values, t now is equal to the square root of 2 times 3.15 meters over 9.81 meters per second square. Calculating, t now is equal to 0.801 seconds. This is a time na kailangan i-take ng fruit para ma-reach yung ground with the acceleration due to gravity. Next naman, for letter V, gamitin muna natin itong first equation na to. Pwedeng gamitin sila both, pero let's start with this equation. alam na natin yung time na 0.801 seconds. So, pwede na nating masolve itong V na to. Itong VO natin or V initial is 0. So, V equals acceleration due to gravity na 9.81 meters per second square times the time na nasolve natin, we have 0.801 seconds. So, cancel. V is equal to 7.86 meters per second. Ito yung ating initial velocity gamit itong equation na to. Try natin yung pangalawang equation. This equation, again, the initial velocity is 0 and meron tayong delta y. Yung delta y na yan is equal to the final position since 0 yung ating initial position. So, v square equals 0 na yung v sub o square. This is 2g delta y or simply y na lang siya. Yung y na yan is yung 3.15 meters. Solving only for the velocity, we take the roots of both sides para makancel yung square. This is v equals the square root of 2gy or delta y. And substituting the numerical values, we have 2 times 9.81 meters per second square times yung 3.15 natin. Calculating, V is equal to 7.86 meters per second pa din. So, same sila ng naging answer with a different approach and with different equation. So, this is example number 1. Example number 2, a volcano shoots out lava bomb from its summit. A man observing the eruption uses a stopwatch to time the flight of a particular lava bomb that is projected straight upward. If the time for the bomb to rise and fall back its launch height is 4.75 seconds and its acceleration is 9.81 meters per second squared downward, what is its initial speed? In this figure, yung coordinate system natin, ito, with upward as the positive y direction. This is the y. And for clarity lang, iniusog ng onti itong broken line natin dito, pero straight upward yung kanyang motion. So, nag-travel pa ganun yung lava bomb directly upward and then bumalik siya ng same dito lang din. Iniusog lang ng onti dito para may pakita yung kanyang motion na pababa na yung lava bomb. Ito siya. In addition, we choose that yung time natin, initial time is equal to 0 to be the time at which the lava bomb is launched. Yan yung starting time natin. And with these choices, it also follows that yung y sub o natin or yung starting position is also equal to 0 dahil dyan nag-start yung lava bomb. And yung acceleration natin is 9.81 meters per second square negative. So, bakit naging negative yung acceleration due to gravity natin? Kasi, yung first direction ng lava bomb natin is upward. Directly opposite sa direction ng gravity na laging pababa. And with this, the initial speed to be determined is yung v sub o. Ito. Nag-start dito yung lava bomb, mayroon na siyang initial speed agad. Yun yung kailangan nating hanapin. And once again, i-ignore ulit natin yung air resistance and i-model natin tong motion of the lava bomb as free fall. But this time, meron tayong initial upward velocity na siyang ang hinahanap natin. And we know that the lava bomb starts at the y sub o, starting position as 0. And time 0 returns to, dito pa din siya nagbumalik. So, nag-travel yung lava bomb papaganyan. Bumalik din siya dun sa starting position niya sa y sub o equals to 0 at the time na 4.75 seconds na. So, nag-travel siya from here, dito sa starting position, bumalik siya, nag-travel siya, bumalik siya hanggang sa starting position then at the time of 4.75 seconds. So, ibig sabihin that alam na natin yung bomb's position, time, and yung acceleration which is negative 9.81 meters per second square from which we would like to determine the initial velocity. With those relative variables, position, time, and acceleration, ang gagamitin natin na equation is y equals y sub o plus v sub ot plus 1/2 gt square. Again, pwedeng lagay lang din natin dito as x. Ginamit ko lang na y dahil vertical na yung ating motion na sinusolve. And using this equation, ang unknown lang natin dito is yung v sub o. Alam na natin yung initial position, eto, 0 na yan. Ang final position niya ay dito din. So, yung y sub o natin is equal to y dahil pareho siya ng binagsakan. Kung saan siya nag-start, doon din siya bumagsak, 0 na din ito. Ang hinahanap natin is the initial velocity, ito. Alam natin yung time, we have 4.75 seconds, and we have the gravity. So, masasolve na natin yung initial velocity. So, this is 0 equals v sub o t plus 1 half g times t square. Solving for the initial velocity, ilipat natin ito sa other side of the equation. We have negative 1 half gt square equals v sub o t. Naging negative, nilipat natin siya sa kabila. At pagpalitin ulit natin, we have v sub o t equals negative 1 half gt square. Solving only for the initial velocity, we divide both sides by the time. Para makancel ang matila lang is yung initial velocity. So, sa right side of the equation, makakancel isang time. We have negative 1 half gt. And pwede na natin i-substitute yung given values natin. V sub o is equal to negative 1 half. Ang gravity natin is negative 9.81 meters per second square. Again, kasi yung initial motion ng freefall natin is pataas, which is directly opposite sa direction ng gravity na pababa. Meters per second square times the time na 4.75 seconds. Maka-cancel yung isang s. Matitira lang sa atin is meters per second. And by calculating, the initial velocity is equal to 23.3 meters per second. So, this is the initial speed of the lava bomb na nag-travel lang 4.75 seconds and bumalik lang din dun sa initial position. So, yung observer can determine or pwede niyang malaman yung initial speed ng lava bomb by simply observing the time of flight ng lava bomb. And this is example number 2. Example number 3. A hot air balloon is rising straight upward with a constant speed of 6.5 meters per second. When the basket of the balloon is 20 meters above the ground, a bag of sand tied to the basket comes loose. Letter A, how much time elapses before the bag of sand hits the ground? And letter B, what is the greatest height of the bag of sand during its fall to the ground? Ang motion ng hot air balloon is straight upward dito. Directly pataas yung motion niya. Pinapakita lang ulit dito kung ba't ganito yung naging motion ng hot air balloon natin para mas ma-visualize natin yung pagbagsak ng sand na natanggal dun sa hot air balloon. We choose the origin to be at the ground level to be positive upward. Ito yung ating origin, the y sub o equals 0. In this problem, magpo-focus na tayo dun sa mismong motion ng bag of sand na natanggal dun sa hot air balloon. And for the bag, we have the 20 meters. Ito, meron tayong nakita dito na 20 meters and that is the initial position of the bag. So, natanggal yung bag of sand nung yung hot air balloon ay 20 meters above the ground na. So, ang y sub o natin, or the initial position natin for the bag is 20 meters. And yung initial velocity nung bag is 6.5 meters per second. Bakit naging 6.5 meters per second yung initial speed nung sand, nung bag of sand? Kasi, yun yung constant speed nung hot air balloon. So, nandun na siya sa 20 meters dito sa part na to, na may motion na 6.5 meters per second speed yung bag of sand. Yun din yung naging kanyang initial speed nung nandun na siya sa part na natanggal na siya dun sa hot air balloon. And yung kanyang acceleration is the gravity pa din, which is negative 9.81 meters per second square. So, bakit naging negative 9.81 meters per second square ulit? From here, dito nag-start yung hot air balloon natin, papaganyan siya at nahulog yung bag of sand na para bang ibinato niya pataas. Ibig sabihin, yung motion ng bag of sand natin is directly opposite sa gravity, yung initial motion niya. For this problem, i-ignore ulit natin yung air resistance dun sa bag of sand. For letter A, how much time elapses before the bag of sand hits the ground? And gusto nating i-relate dito yung position and yung time. Knowing the initial position, alam natin yung initial position and alam din natin yung initial velocity. Ang gagamitin natin na equation for letter A is y equals y sub o plus v sub o times t plus 1/2 a t square. For letter B naman, we have no expression that gives the maximum height of the particle. So, ang gagawin natin, we have to come up with something on our own. And we can start with the fact that yung velocity natin is equal to 0. And we can start with the fact that yung final velocity natin is 0. Another reminder, kapag sa free fall, and na-reach niya yung greatest height niya, say ito yung ating object, and once na na-reach niya yung height niya, ibinato siya pataas na ganyan, na-reach niya yung height niya na yan, at bumaba siyang ganyan, ibig sabihin, itong na-reach niya na height na yan is greatest height. And nung huminto na siya dito, ibig sabihin, huminto siya kasi wala na siyang velocity. 0 na yung kanyang velocity dito sa top. Yun lagi ang kailangan natin tandaan kapag maximum height ang hinahanap, yung velocity niya sa top ng height na yon is 0. Let's start with letter A muna. So, using this equation, i-apply natin itong equation na to the bag of sand. And to do this, we let yung acceleration natin as the negative 9.81 meters per second square acceleration due to gravity. And isi-set natin yung final position, this y, as 0. Ang initial position natin is ito, y sub o. Dito sa position na to, natanggal yung bag of sand. And ang final position, yung bumagsak na yung sand is dito. This is the final position and this is 0. Nasa ground na siya. Dahil ito yung ating reference of the position natin, which corresponds to the ground level. So, substituting, 0 na yung y natin, this is 0 equals y sub o plus v sub o t plus 1/2 g t square. So, rearrange natin. Say, this is 1/2 g t square plus v sub o t, binaliktad ko lang, plus y sub o equals 0. Kung mapapansin natin, this is a quadratic equation. We have t square here and t. Therefore, pwede natin itong applyan ng quadratic formula to solve for the time. This is the A, ito yung ating B, and ito yung ating C na gagamitin natin sa quadratic formula for t. We have, ang B natin, negative B is yung V sub O. So, this is negative V sub O. Plus or minus, sa quadratic formula ito, the square root of B square. Ang B again natin is V sub O. So, this is V sub O square minus 4AC. Ang A natin is ito, 1/2 times negative 9.81 times ang C natin is yung y sub o over 2a. 2 times 1/2 times negative 9.81. Pwede na nating masolve yung time using the quadratic formula. But, dalawa yung masasolve natin dito dahil dito, plus or minus, dalawa yung magiging value ng time natin. So, pipiliin natin yung kung ano yung possible answer for the time. T equals, ang V sub O natin or initial velocity natin is 6.5 meters per second plus or minus the square root of 6.5 square minus 4 times 1/2 times negative 9.81 meters per second times ang Y sub O natin is 20 meters, square root yan, over 2 times 1/2 times negative 9.81 meters per second square. Calculating, and i-simplify natin, this is negative 6.5 plus or minus, calculate natin itong value na to, we have positive or negative 20.8 meters per second over, ang value nito when calculated is negative 9.81 meters per second square. The two values of the time natin now is equal to positive 2.78 seconds and negative 1.46 seconds. Since dalawa yung value ng time natin, ang pipiliin natin na value is yung positive 2.78 seconds kasi hindi naman nagiging negative yung time natin. For letter B, we use the equation V equals V sub O plus GT to the bag of sand and isosolve natin yung time when the velocity equals 0. Again, reminder, final velocity equals 0. Kasi ang sinasolve natin dito is yung greatest height. And sa greatest height niya, yung pinaka-tuktok nung height na yon is nag-stop na yung object and pabagsak na siya ulit. Ibig sabihin, nag-stop na yung kanyang motion. Kaya na siya bumalik pababa. Final velocity is 0. And we have still the initial velocity na 6.5 meters per second. And the gravity na 9.81 meters per second square. So solving for the time, this 0 equals V sub O plus the gravity times time. So solve natin ito, ilipat natin yung V sub O sa kabila. This is negative V sub O equals GT. And solving for time, divide both sides by the gravity. Cancel, cancel. Time natin now is equal to negative V sub O over G, whereas yung gravity natin is negative 9.81 meters per second square pa din. Substituting the values, you have negative 6.5 meters per second over the gravity na negative 9.81 meters per second square. Kumakancel yung dalawang negative and time natin is now positive 0.66 seconds. Ito yung time na gagamitin natin to solve for the maximum height using the equation naman na y equals y sub o plus v sub o times time plus 1/2 gt square. Ang hinahanap na natin is ito, y max, maximum height. At sa maximum height na yan, itong time na to is yung time lang na na-reach niya yung height. Ibig sabihin first motion lang ito. So for example, ito yung bag of sand. Ito yun, yung natanggal dun sa hot air balloon. Mabot siya dito. Ito yung kanyang maximum height. Etong time na to, ito lang yung time na na-reach niya tong maximum height. Y max is equal to, ang initial position natin is 20 meters pa din, plus initial velocity na 6.5 meters per second times yung time na 0.66 plus 1/2 times negative 9.81 meters per second square times time again na 0.66 seconds square. And by calculating, y max now is equal to 22.15 meters. So this is the maximum height na naabot ng bag of sand during its fall to the ground. Thus, yung bag of sand natin continues to move upward for like 0.66 seconds. Ito nga yun. After it separates dun sa basket ng hot air balloon, reaching a maximum height na 22 meters above the ground, and then begins to move downward and bumagsak siya hanggang dun sa ground with the time na 2.78 seconds. This is example number 3.